Let's learn about real numbers on the number line. Um, Kind of an important idea because you have to have a concept of where numbers are located, especially progressing through algebra. You want to know where the position of everything is because eventually you do more things with it. So let's just break this topic down. So we know that any real number can be graphed on a number line. Sometimes it will be in an exact location. Sometimes, however, it might have an approximate location. Usually an approximate location is sufficient for what we're doing, but I will do an example where you can, focus on getting more exact. However, like irrational numbers are not ever going to have an exact location. You would have to kind of approximate them somewhere and round them off. Now, the general structure of a number line, we sketch a line and we generally will put arrows on either end to indicate that it goes on without bound in both directions. So we know this direction to the right is considered the positive direction where the numbers are getting larger. So we also will indicate that with a positive infinity. And then going this direction, the numbers are getting infinitely smaller. So we indicate that with what we call a negative infinity. And so as you go from left to right, kind of like you're reading a book, the numbers are going to always increase. A good idea is to locate zero because we know zero is neutral, neither positive or negative. And so we know the positive numbers live to the right of zero and the negative numbers live to the left of zero. So we're going to plot a few examples. So I have a couple listed here. So example one, there's five values that we'll plot. These are a mix of fractions, some decimals, and we even have some whole numbers as well. So I went ahead and sketched a number line, but you'll always, like I said, want to sketch a number line. And we want to put a scale on it. So like from here to here, the distance from like each tick mark would be what's considered your scale. So I just labeled all of mine with a scale of 1 unit. So everything is just counting, from 1, 2, 3, and so forth. In this direction, -1, -2. Um, so sometimes you need them to be more detailed. Sometimes you just need a general sketch or idea. But for this one, we're going to get approximate locations for some of them because they won't necessarily land on a tick mark. So let's go ahead and plot these few values that we see here. So starting with -7.2, this one we know is going to be, it's more negative than -7. So it's going to have to live to the left of -7, but not quite as far as -8. So to get it in a better approximate location, you want it to really end up being closer to -7. You can think of if you divided this into 10 little sections, point 2, right? Because point 1 would be represented by one of those if you divided it in 10. So point 2 would still be close to -7. So we're just going to put something relatively close to -7. And then we're going to call this -7.2. All right, 1/4, our next number, that's going to be a number in between 0 and 1. So you can think of the same idea, but this time we could divide this into 4 equal sections. And we would just want to look at one of those sections. So this is going to be closer to 0 than it is to 1. So 1/4 is going to live somewhere about there. 5, however, lands right on a tick mark. So we would say that one has an exact location on this particular number line. -2.5 will be directly halfway in between -2 and -3. And then the last number in this set is 3.8. So that's going to be a number between 3 and 4. But once again, it's going to be closer to 4 this time. And so we want to demonstrate that it's going to be closer to 4 than to 3. So we'll put it there and we'll call this 3.8. Okay. Now let's look at the next example. Okay, so I still have 5 numbers and I've already got the number line drawn as well, but go ahead and sketch your number line. And I did the same scale. So everything is represented, the tick marks are represented by one unit. And some of these you can see like -9 and 0, we could go ahead and plot those pretty quickly because we know those are going to land right on an exact location. So here's 0, here's -9. Now let's go back and look at this one. All right, so 5 halves is going to be greater than 1, right? It's actually greater than 2. It's going to be 2.5 exactly. So 5 halves is going to live halfway in between 2 and 3. So we'll put 5 halves right there. -1.2 is our next one. So very similar manner that we did up there. We know this is going to be more negative than -1, but still closer to -1 than it is to -2. So we'll call that -1.2. Now, 2.3. This one is awfully close to that one, right? So 5 halves, we said that's really 2.5. Well, 2.3 is going to be, kind of a third of the way. So they're going to be very close. Maybe I will use a different color, so if I put it right there, like that's going to be a 2.3. But you can see that those are really close. That's fine. You can still see both of them. If you wanted to, you could even zoom in and change the scale. So let me give you one example of that. So for this one, I could come out here and I could maybe make this distance because I have a 2.3 and I have a 2.5. You could even sketch a whole nother line. Okay, look something like this. And we can put 2 on one end, but then we can count by 0.1. So we can make our scale like the next tick mark over. See, that can be a 2.1 and a 2.2. So you could zoom in on this, if you will. And then each of these numbers would now have an exact location. Okay, so we'll end the number line here, and I'll make that a 3. Okay, so I'm going to just have this little portion that we zoomed in on from 2 to 3, and then you can plot them like this. So 5 halves would now actually have a home. It would land on that position. And then 2/3 also would have a home, and it would land in this position. Or not 2/3, my bad, 2.3. Okay, so now you can see if you were to zoom in on this little segment, it would look like that. Okay, now go try a few that are on the worksheet and practice plotting real numbers.